Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay. Firstly, for our group project, we choose a Spotify. The title is Spotify. Uh, and then let me introduce my teammate. Okay. First is Muhammad Ajwad Akhari bin Abdullah. Second is me, Abdul Hadi bin Muhammad Najib. Third, Muhammad Ayub Daniel bin Jamaluddin and Akman Hakim bin Syamsuddin. Alright. Uh, the title that we choose is Spotify application double link list. Okay. Link lists are essentially a collection of nodes where each node contain a value and a reference to the next node. Firstly, node which is a container that stores the data and the memory address the next nodes. Second, next is block within a node responsible for storing the next node memory address. Lastly, previous block within a node responsible for storing the previous node memory address. Okay. Next is Spotify operation. That we have a three operation in this Spotify. First is back forward for the music playlist. Second is add music to the music playlist. And last, remove music from music playlist. Okay. Spotify operation. Okay. What is back and forward music playlist? Okay. By pressing the next button on the music player, uh, it will select the next song to start playing. All the song notes are connected to each other via link. This allow us to traverse back and forth between songs. Okay, next, second is add music to the playlist. Okay, uh, in Spotify, we can create a new note and add it to the end of the link list by updating the tail node pointer to the point to the new notes. Okay. And lastly is remove music from the playlist. Okay. We can create a new node and add it to the end of the link list by updating the tail node pointer to the point to the new node. Okay, next I will pass to the next presentator, Ayub.
Okay, thank you, Abdul Hadi, for the great introduction of Spotify Spotify data structure as an algorithm. So next, I will be presenting about the Spotify storage patterns. So we move forward to the back or forward music playlist operations. How it will be affected of the back end. So firstly, we have to assume that we have three songs on our playlist. So in the back ends, as we all know, the nodes that contain the song data and separate memory address. So let's look to the song one, song two, and song three. We can see that song one holds the data and also the next memory address. They don't have the previous memory address because it is the first or it is the head of the nodes, and also which is the song three. It holds the tail of the nodes, so it will be there will be no next memory address. So as we all know, all the song nodes are connected to each other via a link. As we can see that there will be a line, which is we have a two-way line. We can go and also we can go rewind back. So this allows us to traverse back and forth between songs. So assume that by pressing the next button on our music player, we will select the next song to start playing. So in the back end, the current song node will check the memory address stored in the link and also travel to the next song node and load the data stored in the node. So as we can see here, for example, song one and song two. So we can see that song one holds the next memory address, which is 1000. So if we pressing the next button on our music player, the song two will be playing the next memory address of song one, which is 1000. So next slide. So next we will be covering about the operation of adding a new song to the playlist. So how will be affected Spotify storage pattern. So assume we want to add song 4 to our playlist. first and foremost, we will travel to the song in our playlist, which is the song 3 that earlier doesn't have the next memory address. So song 3 will store the memory address of song 4, which is 1002. So song 4 will store null as the next node address because it will replace the tail of the song 3, which is null next memory address. So that's how we're adding a new song to the playlist. Next, we will move to the next slide. Okay, let's see about how to remove song from playlist and how will it be affected about the backend. So usually we click on the button to remove a song, but let's understand the logic implementation by looking at the algorithm. So as we can see here, we have 4 songs, which is song 1, song 2, song 3, and also song 4 that we have been added recently. So begin by traveling to a song before song 4, which is song 3. So we have to change the memory address of the next node to null because we want to remove song 4 from the playlist. So we move to the song 3. Next, change the memory address of the next nodes to null. So that's it. You have successfully removed the song from your playlist. Let's see the output of the Spotify storage pattern when we already remove it. So go to the next slide. Yes, as you can see here, song 3 next memory address will be null because we already removed song 4 from our playlist. So that's how we remove the song from playlist. So this is the after process of removing. So I think I already covered about Spotify storage pattern and all 3 operations in it. So I will let it go to the next presenter. Thank you.
Okay, so next, I will explain the estimation of the efficiency of the double linked list application in several Spotify features with code example. Firstly, for find song method, we implement the use of for loop and if else function. The idea behind calculating the efficiency is when a loop is involved in the code and the loop depends on the number of song in the database, the complexity is linear to the time as the time taken to get the result will increase to with the size of the database. So we can consider it as ON, which is linear notation. As for the if statement, the execution time is considered constant or O1 because the function will always have a fixed number of choices. So, however, as the statement is included inside of the for loop, we will make it as n because the if statement will run as the for statement is running. When we total the values, we will get 3n plus 1. Then we will simplify the equation by ignoring the number or integer uh, in the equation, and then we will get on, which is the complexity of the function to find song, linear to time. So next, for method to add song to a playlist, it involves the previous find song method and an if statement. As we calculated find song method before, the time complexity is on, which we noted here for the next code, next to the code. And for if statement, the statement is not under any loop, so it will be considered as one. When we total the values, we will get n plus 4. Ignore the integer and simplify it, we will get the overall worst case running time of add to playlist method is on. Next, for the code to play next or previous song, the features are implemented in a single switch statement with no implementation of loops and if else statement in some of the cases. When no loops is involved in the code, it is considered as constant as the execution time remains the same regardless of number of the cases. Next, so to conclude the efficiency calculation, the overall worst case time complexity of adding song to a playlist is ON. However, the time complexity may change if the user selects song provided in the menu instead of searching for a specific song that they want. This is because the program will not need to run find song function before adding the song to the playlist. And in these features, double linked list is used instead of single linked list because double linked list allow traversal in both forward and backward directions. This allow user to play next song as well as previous song in the playlist. And why linked list is used for these operations instead of queue? Firstly, linked lists are more flexible than queue. For example, you can add or remove element from any position in a linked list, while in queue, its way of implementation is first in, first out, which adding elements only from the rear of the element and removing from head of the elements. Although there is several drawbacks of implementing linked lists, such as lower access and complexity, it is a better way to accomplish the features for the program. So I'll pass to the next presenter.
Sorry, so this example coding from the add music to the playlist. So this one is a code for back and forward music playlist. And the last one is this remove music from the music playlist. And for the conclusion and summary, the double list application can provide many advantage and enhance functionality in a music player. The first one is bi-directional traversal. This is useful for navigating through a song queue and implementing previous and next functionality. And the second, flexibility in playlist manipulations. Double lists provide flexibility in manipulating the playlist structure. Operation like reordering songs, music songs within the playlist, or certain new songs at specific position become more straightforward and efficient with the bidirectional nature of the double list. And the last, implementation of double list may increase memory usage due to the inclusion of backward links in each node and increase implementation complexity compared to a single linked list. So thank you for Hadi for present about the intro and how the Spotify operation. And for the Ahmad, for the Ayu, and thank you for about share about the uh, storage pattern. And for the Ahmad, thank you for explain detail about the how the Spotify running time is so efficient. And that's all from me. Uh, thank you for uh, uh, thank you for Abdul Hadi, Abiyu Adenia, Akmal Hakim for the presenter. And I hope we can see us for the future for the next project. And so on. Thank you guys for all. Assalamualaikum.